A radiator in a room is radiating energy at a rate of 345 watts through a radiant area of 1.8 square meters. It has an emissivity of 0.89, and the room it is in has an ambient temperature of 18 degrees Celsius. What is the temperature of the radiator in degrees Celsius? So let's assume that the room is this, perfect absorptive environment here, right? So we can say what the net power output, right, which is this, right? And this is, let's assume that this is the net, right? So that's going to be the emissivity times sigma times the area times the temperature of the radiator to the fourth minus the temperature of the surroundings to the fourth. Because the room starts with an R too. Okay, that's the radiator, the surroundings. Okay. And we are told that the net power output is 345, right? So if we solve this, we need to solve this for the temperature of the radiator. So let's do that. If we do that, we are going to get, let's see, what's the next step? That equals E sigma area, temperature of the radiator to the fourth, minus E sigma area, temperature of the surroundings to the fourth. So let's see, what can we do here? We're going to go power plus E sigma area, temperature of the surroundings to the fourth, divided by E sigma area. That's going to be temperature of the radiator to the fourth. So all we have to do is take the fourth root of this, right? Raise this to the 1/4 power, and we'll have the temperature of the radiator. Okay. The temperature of the radiator is equal to the power, which is 345, right? Plus emissivity is 0.89 times sigma 5.67 times 10 to the minus 8th. Our area is 1.8 square meters, right? And then the temperature of the surroundings, it's 18 Celsius, right? So 273.15 plus 18 is 291.15 kelvins. We'll just go with that. All right, and then that is divided by 0.89, which is our emissivity, times sigma times the area, which is 1.8. And you can't cancel it because there's a term there, okay? And then this is all of this to the 1/4. This is like higher mathematics. Look at that expression. All right, I'm actually going to use the fraction key on my calculator. So I'm going to go left parenthesis, alpha F1, enter, 345. I'm in the numerator right now, plus 0.89 times 5.67 times 10 to the minus 8th times 1.8 times 291.15 raised to the fourth. That's important. Okay, now I'm going to go right arrow. I'm going to go down to the denominator, 0.89 times 5.67 times 10 to the minus 8th times 1.8. So I'm done with the denominator. Let's go to the right of this, right parenthesis. And I'm going to raise it to the 0.25. 323. Okay, let's see, 323.73. Did I get that right? 345.89. I'm getting 323.7, which looks like a different number. All right. It's 1.8. All right, so let's see, minus 273.15, and that's 50.58. Now that's the right number. So I get 50.58 degrees Celsius. So what I did was I subtracted 273.15, and then I got an answer in Celsius, which is what we got. All right. All right. Hey, we got the right answer. Okay, good enough.